Alright, now we're going to be looking at how do we differentiate trigonometric functions and their inverses. And we're going to start with trig inverses. We look at trig functions a little bit later. So, differentiating trig functions and their inverses. So here, y is equal to sine inverse of x. I want you to think about this. Now, if I tell you to find sine inverse of 30, sine inverse of 30 with your calculator in degrees, you're going to get 0.5, right? Now, if I had asked you for, no, my apologies, sine inverse of 0.5 rather. Sine inverse of 0.5. Sine inverse of 0.5, you get 30 degrees. Now, what if I had asked you to find the sine of 30? The sine of 30 would be 0.5. Now, look where I'm going with this. Look at the connection. Change this 0.5 to x. So, if sine inverse of x is equal to y, then the sine of y is equal to x. Can we see that? So this is what we're saying. If the sine inverse of x is equal to y, then what we're saying is that the sine of y is equal to x. So then the sine of y is equal to x. Right? And so from this part right here, we can then say that, okay, what this is telling me then is that the sine of y is equal to x. So this question is telling me the sine of y is equal to x. If the sine of y is equal to x, we can differentiate this function implicitly to get that, okay, the derivative of sine y is cosine y, and so, but then, remember, we're differentiating y with respect to x, we have to multiply it back by dy by dx. And so we get cos y dy by dx equal to 1. Remember, that's implicit differentiation. And so if dy by dx is equal, cosine y times dy by dx is equal to 1, what we're then getting is that dy by dx, if we divide both sides by cosine y, we get that it is 1 over cos y. Nice. Now look what I'm going to show you now. Now consider this. Now, what is sine square y plus cos square y? So we learned long ago that sine square y plus cos square y is equal to 1. And so if sine square y plus cos square y is equal to 1, what that is telling me then is that if I were to make cos y the subject, I would get that cos square y is equal to 1 minus sine square y. Cos square y is 1 minus sine square y. And so what that is telling me then is that the cosine of y is equal to 1 minus sine square y. And then I take the square root of all of this. That's what that is telling me. In order to get cos y, we have to take the square root of both sides. So cos square y is 1 minus sine square y. We take the square root to get what is cos y. And so now we can make a substitution for cos y right here, so that that becomes 1 over, this cos y is now the square root of 1 minus sine square y. 1 minus sine square y. And that's dy by dx. Right. Now look at this part now. Now, remember, we said that sine y is equal to x. And so if I were to square both sides, what I'm then telling you then is that sine square y would be equal to x squared. And so what I'm then saying is that dy by dx is equal to 1 over the square root of 1 minus x squared. And And so that's how we differentiate sine inverse. And so in general, what the rule is, so let's write down what the conclusion of the rule is. So the rule is if y is equal to sine inverse of function of x, then dy by dx is going to be equal to 1 over the square root of a function. So let's write it down. So this is the conclusion. If y is equal to sine inverse a function of x, y is equal to sine inverse a function of x, then dy by dx, or y prime, then y prime is equal to 1 over the square root of 1 minus f of x all square, 1 minus f of x all square, and then we times it by f prime of x. And we times it by f prime of x. And that's how we find the derivative of a trig function. So let's look at an example. So let's say I gave you that y is equal to, let's say y is equal to sine inverse, the sine inverse of 3x. If y is equal to the sine inverse of 3x, then dy by dx is going to be equal to 1 over the square root of 1 minus f of x all square, which is 1 minus here. F of x is 3x all square, and then you multiply it by the derivative of your 3x, which is 3. So what we get then is that this becomes equal to dy by dx, which is 3 over the square root of 1 minus 9x squared. So that's your dy by dx, or your y prime. Right? Your y prime is 3 over 1 minus 9x squared. That's your y prime. Alright. Now the next thing to consider is if y is equal to the cosine inverse of x. If y is equal to the cosine inverse of x, then how are we going to find dy by dx? Now it's pretty much the same. Sine and cosine is the same thing. It's the same method. Now this is what we do for cosine. Now y is equal to cosine inverse of x. So then remember, what we can then say is cos y is equal to x. Right? We can then say cos y is equal to x. Remember the example that we use. Right? So if y is equal to cosine inverse of x, then cos y equal x. We can then differentiate both sides with respect to x to get, when we differentiate cos y, so remember step 1 now, you differentiate both sides with respect to x, and so what we get is the differential of cos y is 1 over sine y. So we differentiate cos y, my apologies, when we differentiate cos y we get minus sine y, and then when we differentiate y, we always multiply by dy by dx. When we differentiate x, we're just going to get 1. And so what we end up getting is that dy by dx is equal to minus 1 over sine y. That's dy by dx. But remember what we had said. We had said clearly that right here, remember we said that sine square plus cos square is 1. So just to recall, sine square y plus cos square y is 1. Sine square y plus cos square y is equal to 1. And so what we're then saying is that sine square y is equal to 1 minus cos square y. That's sine square y, 1 minus cos square y. And so sine y is then equal to the square root of 1 minus cos square y. So sine y is the square root of 1 minus cos square y. That is sine y. And so dy by dx is going to be equal to minus 1 over sine y is the square root of 1 minus cos square y. But now look at this. Cos y is x. And so cos square y is going to be x squared. And so dy by dx is minus 1 over the square root of 1 minus x squared. And that's the derivative of cos inverse of x. So the general rule is if, this is a general rule now, so if y, this is kind of an intuitive proof of how they get the results. So if y is equal to cosine inverse of a function of x, if y is equal to cosine inverse of function of x, then dy by dx, is equal to, dy by dx is equal to minus 1 over the square root of 1 minus f of x all square, 1 minus f of x all square, and then we multiply it by the derivative of f of x, which is f prime of x. That's how we differentiate cos. So that's how we differentiate cosine inverse functions. So let's look at an example. Typical example. Let's say y is equal to cosine inverse. Let's say y is equal to cosine inverse x over 3. If y is equal to the cosine inverse of x over 3, then dy by dx is going to be equal to minus 1 over the square root of 1 minus f of x all square. So it's 1 minus, your f of x in this case is x over 3. So it's 1 minus x over 3 all square times your derivative. When you differentiate x over 3, you're getting 1 over 3, right? And so now, what dy by dx simplifies to be is, now look at this, we can write this as minus 1 over the square root of, now look at this carefully. Now when you expand this, you're going to get x squared over 9, right? And I'm going to rewrite 1 as 9 over 9. We can always rewrite that as 9 over 9. And remember, we're multiplying by 1 over 3. Can always do that. Now, the key thing right here now is right here we can factorize out 9. So in the denominator, we can factorize out 9 to get minus 1. We're going to factorize out the square root of 9. So factorize out the square root of 9. And what we're left back with is, we factorize out the square root of 9, right? So factor out root 9. Or how some would see it is, let's not even look at it as factoring out root 9. Just look at it as you're factoring out 9 from these two numbers. So if you're factoring out 9, what you end up left back with is 1 over 9. We factor out 9. My apologies. We're factoring out 1 over 9. Remember, we always factor out what is in common. So we're factoring out 1 over 9. And so what we get now, factoring out 1 over 9 from this, leave me back with 9 minus, factoring out 1 over 9 from this, leave me back with x squared, right? And then we're still multiplying by 1 over 3. Now, we can then find the square root of 1 over 9, and the square root of 1 over 9 is just going to be 1 over 3. And so this minus 1 times 1 over 3, in the numerator, we can then write 1 over 3 divided by this square root of 1 over 9 is just 1 over 3. And this 1 over 3 is then being multiplied by the square root of 9 minus x squared. Nine minus x squared. And so this 1 over 3 cancels this 1 over 3. And so this just becomes 1 over 9 minus x squared. Alright, so if we were to just write the result at the top, so we can then just clearly see that y prime is equal to 1 over the square root of 9 minus x squared. That's how we find the derivative of y equal cosine inverse of x over 3. Alright, so that's dy by dx. So this is the answer. Finally, let's look at how we find the derivative of tan. How do we find the derivative of tan? Now tan is similar to sine and cosine. So of course we're going to start that if y is equal to tan inverse of x, then tan y is equal to x. Now if tan y is equal to x, we can differentiate both sides with respect to x to get the differential of tan y is sec square y. Sec square y. We differentiate tan y, we get sec square y, and then we multiply it by dy dx. We multiply it by dy by dx. And then what the answer is the result gives us 1. So sec square y times dy by dx, and the answer gives us 1. And so now, if we make dy by dx a subject, we will then get that dy by dx is equal to 1 divided by sec square y. That's dy by dx, 1 divided by sec square y. Now pre this. Remember, sine square y plus cos square y is 1. Sine square y plus cos square y is equal to 1. So if we were to divide through this entire equation, let's say we divide it through by cos. If we divide it through by cos square y, so we're going to divide the entire equation by cos square y. What we get is sine square over cos square y is tan square y plus cos square y over cos square y is 1, and 1 over cos square y is sec square. And so what we're getting then is that tan square y plus 1 is sec square. So we can replace dy by dx, the sec square part, with tan square y plus 1. So we can replace sec square with tan square y plus 1. Now tan of y is x, and so tan square y is x squared. And so dy by dx works out to be 1 over x squared plus 1. So that is dy by dx. So that's how they create the derivative of tan inverse. Now the general rule is if y is equal to tan inverse of a function of x, if y is equal to tan inverse of a function of x, then dy by dx, or y prime, then y prime is equal to 1 over f of x all square. So it's equal to 1 over f of x all square plus 1 times f prime of x. That's how you differentiate tan inverse functions. Alright, so let's look at an example here. So example is, let's say y is equal to, tan inverse x cubed plus 2x minus 3. Y is tan inverse x cubed plus 2x minus 3. Then dy by dx is just going to be equal to 1 divided by f of x all square. Your f of x all square is just x cubed plus 2x minus 3 all square plus 1 times your f prime of x, and your f prime of x is 3x squared plus 2. That's your f prime of x. And so what we're getting then is that dy by dx is equal to 3x squared plus 2 divided by x cubed plus 2x minus 3 all squared plus 1. And that's how we differentiate tan inverse a function of x. All right? Easy, soft.